All right, let's do some multiplication with complex numbers. And when you're doing these problems, you want to make sure it is a multiplication problem and not addition or subtraction. To determine that, you would look between your set of parentheses. If there's a plus or a minus sign here, you're doing addition and subtraction and not multiplication. But since the parentheses are right next to one another, there's no symbol between. That means we are multiplying. Okay, so we do similar to FOILing. We take everything in this first set of parentheses times everything in the second set. So I'm going to take the 2 times everything in this set. I'm just going to distribute. So 2 times -1 is -2. And then 2 times -3 is -6i. Now we do the 4. Okay, so 4i times -1 is -4i. And 4i times -3, 4 times 3 is -12, and I times I is I squared. Okay. To simplify from here, there's a couple of things we need to do. We need to combine like terms, and we can't have an I squared in a simplified. We can have I, but not I squared. Now, if you've forgotten from algebra, I squared is equivalent to -1, because I is the square root of -1. When you square it, you get -1. Okay, so know that I squared is equivalent to -1. So I'm going to rewrite this. I'm -12 minus 6i minus 4i. This would be -12 times -1. I just replaced the I squared with a -1. -12 times -1 is a positive 12. Okay, and in the future you can do that in less steps, but I just wanted to make sure you saw how I got that positive 12. We want to combine like terms. Okay, so the -2 and the 12 is our real parts, those are real numbers, and the -6i and the -4i are the imaginary part, the i's. -2 plus 12 is a positive 10, and -6 minus 4 is -10. So my answer to this multiplication problem is 10 minus 10i. Let's take a look at the next one. So we have multiplication here, I know, because there's no symbol between my parentheses here. So I go ahead and distribute. I'm going to start with my 3 and take it times everything in this second set of parentheses. So 3 times -1 is -3. 3 times -5 is -15i. -4i times -1 is a positive 4i. Negative times negative is positive. And -4i times -5i, -4 times -5 is a positive 20, and I times I is I squared. Okay. All right, again, we're going to simplify this number with the I squared. I squared is equivalent to -1, so we really have plus 20 times -1, and 20 times -1 is a -20. So what we really have is -3 minus 15i plus 4i minus 20. We're going to combine our like terms, so our -3 and -20 can be combined, and the -15i and the -4i, or excuse me, the positive 4i can be combined. -3 minus 20 is -23, and -15i plus 4i is -11i. So my answer here is -23 minus 11i. Not real pretty, but that's our answer. We have 2 more examples here. If you've got it down, go for it. If you want to pause and then just fast forward to see the answer, see how you did, that would work too. Or if you want to go through them with me. All right, so again, multiplication, just double check to make sure that's multiplication, not addition or subtraction. And we start with our 1. We're going to take it times everything in that second set. 1 times 3 is 3. 1 times 2i is 2i. Take the 2i times everything. 2i times 3 is 6i. And 2i times 2i. 2 times 2 is 4. And I times I is I squared. Again, simplify this I squared. I squared is -1. Okay, so 4 times -1 is a -4. So I have 3 plus 2i plus 6i, and this is -4. Right? I have 3 and -4 go together. The 2i and the 6i go together. 3 minus 4 is -1, and 2 plus 6 is 8i. So we get -1 plus 8i. And you may, in the end, probably shortcut some of that a bit once you get used to using that I squared. All right, next, here we go. 5 times 2 is 10. 5 times 4 is 20i. 3i times 2 is 6i. And 3i times 4i is 12i squared. That gives me 10 plus 20i plus 6i. And because I squared is -1, -1 times 12 gives me a -12 here. So I'm shortening it up a bit each time. All right, combine our like terms. So 10 and -12 would go together. 20i and 6i would go together also. 10 minus 12 is -2, and 20 plus 6 is 26i. Well, there we go. There are some multiplication problems for us to practice multiplying complex numbers.